know how this operator works behind the scenes. This is a little bit different from the regular division operator that only has one bar. This is called the floor division operator. Let's see the differences between the regular division operator and the floor division operator. This is an example of a division performed with a regular division operator. 5 divided by 6. We see this result with 16 decimal digits after the comma. We can see them right here, divided by blocks of 3. That is when we use the regular division operator. But if we divide 5 by 6, using floor division, we get 0, with no digits after the comma. We have no decimal digits. And why is that? What happens is that the floor division operator truncates all the decimals in the result that we would get if we divide the numbers using the regular division operator. If we take this result and we remove all the decimal digits, then we would only have the value 0. And that is exactly what the floor division operator keeps. It only keeps the integer part of the result. You can see the difference right here. When we use the regular division operator, we get the whole value with all the decimals. But when we use the floor division operator, only the integer part is kept, the number 0. The name of this operator comes from mathematics. The floor function in mathematics rounds a number down. It gets you the nearest integer down. In this case, that would be 0. And that is the result that we get from this operator. Now let's see some practical examples in the interactive shell. If we divide 5 by 2 using the regular division operator, then we would see the result 2.5. But if we use the floor division operator, we would get 2. Because the decimals would be truncated, they would be removed completely, and only the integer part would be kept, which in this case is 2. Let's see another example. If we divide 1 by 6, we see this result. 0.1666666 for 16 decimal digits. But if we use the floor division operator, we see the result 0. All these digits were removed and only the integer part was kept. Now let's try a third example. If we divide 56 by 27, let's say, we get this result. 2.0747074 and so on. But if we use the floor division operator, we just get the value 2. All of these digits are removed. Great, so now let's see something very interesting. What do you think will happen if we use the floor division operator with floats? That's right. What if the operands are floats instead of integers? Well, the result will be a whole integer, but not necessarily of type int. You will see what I mean in just a moment. Here we have some examples of the floor division operator used to divide floats. As you can see, all of these values have decimal digits. We are dividing, for example, 5.3 by 3.5. That result is 1.0 if we use the floor division operator. Of course, that is not the exact value. What happens is that only the integer part is kept, but 0.0 is added as the decimal to be consistent with the data type of the operands. Since both operands are floats, then the result is a float too. But the decimal digit that is added is 0.0. In the second example, we are dividing 2.3 by 7.8. The result is 0.0. The integer part of the result was 0, and 0.0 was added to stay consistent with the data type of the operands. Similarly, in this example, 33.5 divided by 5.4 using floor division is 6.0. The integer part of the result was 6, this is the part that was kept, and 0.0 was added to be consistent with the data type float. Great! Now, if you want some additional practice, try to find the result of these operations. 4 divided by 5 using floor division, 2 divided by 8 with floor division, 154 divided by 3 with floor division, and 12.4 divided by 3.4. Share your results and thoughts in the comments below. And don't forget to subscribe to find more videos on Python, Java, and computer science in general. You will be the first to know when I publish new videos.